Hello, welcome back to HT STEM. Today we're going to be watching a video about hydrogen. So without further ado, let's hop to it.
So we're braving the elements, Brady, to repeat an experiment that we did quite some time ago. So you'll remember we had a very small balloon of hydrogen. Match on a stick to hydrogen. Big bang coming.
You ready?
Yep, here we go.
That's a big explosion for a little tiny balloon.
And the fact that we've come outside might actually give you an idea about what we're going to do, because we're going to make it a little bit bigger. So let's go and fill a balloon.
Alright, cool.
Well, hydrogen I think is very important because it's the simplest atom. The atom consists of a positively charged proton, which is relatively large, and a negatively charged electron that goes round it.
Electric match.
It's a big balloon, I bet it's going to be a big explosion.
I think an electric match will go well on that.
Yeah.
Oh, look at the tension on the balloon.
Hold it. I've really gone for a blow.
No, yeah. The tension.
What happens is that hydrogen is reacting with oxygen, and
I love this guy's hair. Maybe it'll be me when I'm like a chemist, scientist, kind of mad scientist.
H2 plus O2 reacts to form H2O and an oxygen atom, and then that oxygen atom goes on to react with another hydrogen molecule to make more water. And the reaction generates a lot of heat, and that heat heats up more gas to make it react faster. So you generate more and more heat, so the reaction that begins quite slowly with the first few molecules runs away, and that's why you get the explosion.
So here we have a rather large balloon of hydrogen. Neil is just preparing our electric match, which we're going to attach to the side of this balloon.
And some of the biggest explosions in the 20th century, the Chernobyl reactor, the space shuttle that blew up when it was taking off, were in fact explosions caused by hydrogen and oxygen.
So basically what he's saying is that like two of the most known big explosions, like the Chernobyl reactor and the space shuttle, were both caused by hydrogen, which is kind of crazy. Hydrogen and oxygen, pretty dangerous. Don't try these experiments at home, kids.
So we filled up a balloon of hydrogen. And I think if you look at the hydrogen balloon, you'll see that it's slightly larger than those we've attempted before. Now we're going to try and detonate it, or burn the hydrogen, in the air by giving it a match. And the match we're going to use is again an electric match, which is connected to our detonator box.
If you stick a pin in the balloon will burst because the rubber will break, but the hydrogen will come out, and it won't react with the oxygen because the hydrogen is cool. It's at the same temperature as the air. But the reaction of hydrogen and oxygen, like many reactions, involves a so-called activation energy. You have to put in a certain amount of energy to get it going. But once you get it going, you get more heat coming out than you put in to start it off.
So let's arm the circuit. 5, 4, 3, 2, 1.
That's a big explosion, as we predicted earlier.
That was more like...
Lovely.
When Pete puts the match to the balloon, first of all, the match burns a hole in the balloon, and then the heat gets the hydrogen and oxygen near the outside of the balloon, and they start reacting. And
It's a pretty big, it's a pretty bright flame, you see. Like bright red.
the heat then spreads through the volume of the hydrogen and oxygen faster probably than the balloon is bursting, and as it spreads through, the temperature builds up and up and up because you're generating so much heat. The reason that you hear a noise is because it causes a rise in pressure, which sends a pressure wave out through the air and it hits your ears or the microphone on your camera. I honestly don't know why you see any colour. I suspect that the colour may actually be caused by the burning balloon, which contains carbon and is really like the flame on a candle, because normally when you have a hydrogen-oxygen flame, you don't see any colour at all.
So basically, the bright red fire we're seeing has nothing to do with the hydrogen and oxygen. It's just the balloon burning. Hydrogen and oxygen doesn't have any color at all. It's pretty neat.
Alternatively, it may be some impurities in the gas, but I suspect that what you're seeing in the fireball is just the burning of the balloon. The other thing which is really quite exciting about hydrogen is that, in principle, if you heat hydrogen to really high temperatures, you can get two hydrogen atoms to fuse together.
That's pretty neat. You can like fuse things together if you get them hot or cold enough. I don't actually think cold enough, but maybe different video, we'll see.
Or rather, it will not work with hydrogen, but it will work with a heavier form of hydrogen, which is known as deuterium, where instead of a proton and an electron, you have a proton and a neutron, which is a neutral particle, and an electron. And two molecules of deuterium can fuse together to make one atom of helium, which has two protons, two neutrons, and two electrons. And this produces a lot of energy. It is the basis of the so-called hydrogen bombs, which are like superatomic bombs, but which require an enormously high temperature to get the reaction to go.
So you can probably hear it hissing and fizzing into the bottle there, you know.
There is great hope that in the end, much of the world's energy crisis can be solved by doing this so-called nuclear fusion of deuterium to make helium, which would produce energy extremely cleanly.
So here, we'll just tie it off. If my Welsh hands can actually tie a knot on the end of a balloon, because, you know, we're all a little bit bizarre.
Deuterium gas, in all its properties, will be very similar to that of hydrogen. Of course, it is more denser because it has a neutron as well as a proton, but it's still much lighter than air. So a deuterium balloon will still float up to the ceiling and make Pete look just as stupid as a
Pete looks stupid.
hydrogen one.
Got to keep hold of it.
Or you'll lose it.
Or you lose it, you know.
But I was thinking more about fusing it. That sounds like a really big explosion we could do at the back.
No, fusion reactors are way beyond what Pete can do, unless he's a lot cleverer than I think.
I got a balloon. I had a balloon of hydrogen.
That's the second time you've done that.
No, it's going to go up there eventually anyway.
Thanks for watching, and we'll see you next time. Bye!